में दुनिया ने आग लगा रखी है। नमस्कार दोस्तों, दुनिया गोल है, आप आज यहाँ हैं और आपका एम वहाँ है, बीच में जमाने ने आग लगा रखी है। यही एकमात्र रास्ता है जिस पे यदि आप हार्ड वर्क, कंसिस्टेंसी और परसिवियरेंस के साथ चलोगे तो आप तो क्या, आपका भी पहुंचेगा वहां। Sorry, ladies and gentlemen, let's talk this in the language of physics. If all this refers to speed, which has to be uniform or constant throughout the motion in the circular path, then such a motion is called uniform circular motion. तो भाइयों और बहनों, इन सब के साथ साथ आपको फोकस्ड रहना है। फोकस बहुत ज़रूरी है। आपको इस रास्ते पे चलते हुए बहुत से लोग इस आग में धक्का देंगे, आपको फोकस करते हुए बस इसी पथ पे चलते रहना है। Now this focus refers to the velocity, and you know velocity is a vector. Speed I mentioned should be constant while moving in a circular path if it's a uniform circular motion. Speed, as you all know, is a scalar. It has nothing to do with the direction. Velocity on the other hand is a vector. We need to incorporate direction over here, but since while moving along the circular path, the velocity is continuously changing. Hence, in a uniform circular motion, speed is constant, but velocity is not constant. This is not constant. Now, since velocity is changing, this also means that while moving in a circular path like this, the object undergoes acceleration. तो भाई और बहनों, हमें उठना होगा, हमें समझना होगा इस त्वरण को, इस वेग के परिवर्तन की दर को, इसकी मात्रा और इसकी दिशा को। ट्रांसलेटर, ओवर टू यू। All she said was that let us find out the magnitude and direction of this acceleration. So, okay, now that you all know that we are talking about the uniform circular motion, uniform here refers to the constant speed, the uniform speed, and of course the circular motion is motion along a circular path. I hope this definition is clear, but constant speed does not mean that velocity is constant. As I already told you, velocity is a vector, and since the direction is changing every now and then while moving along a circular path, velocity vector is also changing, and since acceleration is rate of change of velocity, we need to talk about acceleration here. So first of all let us talk about the direction of this acceleration when an object is moving in a circular path like this and undergoing a uniform circular motion. So let us first find out the direction of this acceleration. So if this is the center of the circle, let us first draw the position vectors. Now the initial position of the object is this and the final position is this P dash. So I will be first drawing the position vectors. Let this be R. The position vector of point P is R and the position vector of point P dash is this. This is R dash. ठीक है, and you know that the vectors add according to the triangle law of addition. If you draw a vector A and the other vector such that the tail of the vector B coincides with the head of the vector A, the addition of A and B is like, we draw a resultant like this, which is coinciding with the tail of A and with the head of B. So this is A plus B. This is triangle law of addition. So if this is clear, let me come over here. Now first I will be applying triangle law of addition here. Let me draw a vector from here to here. Like this vector, I'm writing it as delta R. And I denote my delta R like this is R dash minus R. How have I written this? This is nothing but the triangle law of addition. Just look over here. If this is a vector A and this is vector B, then this R dash is the resultant. If you move this R over here, this R dash is the resultant of this. So I can write my delta R like this. That means that the resultant R dash is nothing but delta R plus R. Vectors do not add like scalars. अपने अपने तौर तरीके हैं ज़िंदगी के, इनके ऐसे हैं, स्केलर्स के वैसे हैं, तो इनके जैसे हैं वैसे लिख दिए गए हैं, ठीक है। अब ट्राइंगल लॉ आपको पता है, ठीक है, इसे इरेज कर देते हैं। Okay, so my next step will be to draw velocity vectors at these points, at point P and point P dash. But how to draw this velocity vector? You should know that velocity at a point is along the tangent like this, such that the angle between this position vector and this velocity vector is 90 degrees. Similarly, I will be drawing the velocity vector at this point P dash. Let it be V dash. Again, this velocity vector is along the tangent at that point. So let it be this. This is V dash. And this angle is 90 degrees again. Now you know these velocities are such that the angle with the respective position vectors is 90 degrees. And the second thing that I would like to mention here is that the length of these two vectors should be same. Why? Because we are talking about the uniform circular motion, and I told you that in a uniform circular motion, uniform refers to constant speed, and this length of this vector, the length of this velocity vector is nothing but speed, which is constant for a uniform circular motion. ठीक है, but you should know that these are two different vectors since their directions are different. So I have denoted one with V and the other with V dash. You can see this is along this direction and this is along this. Length दोनों की same है because of this. So you know that this is a triangle and I wrote delta R like R dash minus R. The difference of these two position vectors is delta R. ठीक है. Okay, so after this, another thing that you should know here is that the parallel translation of vectors does not bring about any change in them. What does that mean? If I move this vector over here without changing its direction, this won't bring about any change in this vector. So let me move this from here to here like this. ठीक है, so this is your V. This is the same vector as this. ठीक है, ये P dash बहुत बड़ा लग रहा है, इसको थोड़ा छोटा कर देते हैं. This is this point, P dash. ठीक है, अब यहाँ पे देखो दोनों, the length of vector V dash is equal to the length of vector V. ठीक है, their directions are different. So like I defined delta R, let me define another vector delta V like this. Now this delta V is nothing but V dash minus V. You can again apply triangle law of addition of the vectors and see that this V dash is the resultant of these two vectors. This plus this is this. And please note the directions carefully. Okay, so now before proceeding further, let me define this angle as delta theta. ठीक है, and you know that the sum of the angles of a triangle is 180 degrees. So if I'm taking this in radians, that means that the sum of this and this should be pi. 180 degree is pi radians. So, okay, let me mark this point as C. So when I'm talking about this triangle, I'm talking about the triangle CPP dash. I have named this triangle. Okay, so this angle is delta theta, and you know that this is an isosceles triangle. These two sides are equal. The magnitude of these position vectors is nothing but the radius of the circle. So that means that these two angles will be equal. So if this is x, this is also x. That means that delta theta plus x, that is 2x, should be pi. Or your delta theta is nothing but pi minus 2x. You know that this velocity was along the tangent at this point, and the angle between this position vector and this velocity vector is 90 degrees. So this angle is nothing but pi by 2 minus x. If I write this in radians, 90 degrees pi by 2, so this is pi by 2 minus x. If this is clear, you know that this velocity vector is forming an angle pi by 2 minus x with this delta r. Okay, so now let us move to this triangle. So this delta r is along this direction. So if I extrapolate this, the delta r की direction है, this is the direction of delta r, and you know the angle between this direction and the direction along which the velocity vector v is acting is nothing but this. So this angle is pi by 2 minus x. This p dash is again finding no place. This is this angle. So अभी तक we have written something about this angle, this and this. ठीक है? Now I'm interested to find out this angle. You know that I've simply extrapolated this line. This is essentially a straight line such that this angle plus this pi by 2 plus this x is 180 or pi radians. So this angle plus pi by 2 plus x is pi, which means that this angle is nothing but pi by 2 minus x, which is the same as this. If I add these two angles, what will I get? This complete angle. So what is this? This is pi minus 2x. I think I have seen this expression somewhere. It is nothing but this. So that means that the angle between this v and v dash is also delta theta. So we have reached an important conclusion that all the drama that we did here leads us to the following result, that this angle is delta theta, which is the same as this angle. Take care. And its value is this. So I'm erasing everything else. The angle between v and v dash is the same as the angle between the position vectors r and r dash. Now what do you conclude about the direction of delta v with respect to the direction of delta r? If you observe this, this is again an isosceles triangle because the magnitude of v and v dash is same because of this. The magnitude of velocity is speed, which is constant. So this means that this is an isosceles triangle and these angles are equal. So this triangle is along the similar lines as this, which means that this angle and this angle is x. And you can find out that these are two different triangles and you will be getting this angle as pi by 2. So this angle is pi by 2, that delta v is forming with the direction of this delta r. This delta v is forming an angle of pi by 2 with the direction of delta r. So if I do a parallel translation of this delta v vector, I bring this from here to here, what will I get? You will be getting your delta v like this. Delta v will be perpendicular to this delta r vector. And if you check these two triangles, these angles will be pi by 2 minus x each. That is, this delta v vector is perpendicular to delta r vector and it is bisecting this delta theta. It is bisecting the angles between the two position vectors. तो इतने सारे तामझाम के बाद जिस रिजल्ट पे आप पहुंचे हैं वो क्या है? जो डेल्टा v है, this bisects the angle between r and r dash. और this delta v is directed towards the center of the circle. Okay, so now you know that this average acceleration is nothing but this delta v over delta t. The average acceleration you write down like this, and you know something about the direction. We are finding the direction of acceleration. The direction of delta v is towards the center, which means that the direction of average acceleration, not instantaneous acceleration. Instantaneous acceleration is in the limit delta t tending to 0. So this is average acceleration and the direction of this acceleration is towards the center of this circle. for a uniform circular motion. So now let us check whether we will be getting the same results if we reduce this time interval like small delta time interval. Small delta t. Okay, earlier the point P dash was here. Now since this time interval here is small, this point P dash is here. कम समय में उसी स्पीड से तुम ज़्यादा दूर नहीं जा पाओगे. Now we are interested to find out that the results that we obtained earlier, that the direction of the average acceleration was towards the center of the circle, whether this result will change for this small time interval or not. We are interested to find out this now. So again, what you will be doing? The same procedure. This is the center of the circle. The position vectors, the respective position vectors r and r dash. This delta r, this is this, and this delta r is nothing but r dash minus r. Okay. And again you will be drawing the velocity vectors. These are along the tangent. Let this be v and this be v dash, such that these angles are pi by 2, and this angle again I will be using the same notation as earlier. Let this be delta theta, the angle between the position vectors, and this is an isosceles triangle. Let these angles again be x. These will be pi by 2 minus x. Okay, so now if I extend this direction, this is along the direction of this delta r vector, and if I do a parallel translation of this vector v, so that it comes here, so this is v, and this angle that it is forming here, this is pi by 2 minus x, which is essentially this angle. Okay. And what is this angle? This is again a straight line. This angle plus this will be 180 degrees. So you will be again getting this to be pi by 2 minus x. And if you denote delta v as this will be along this direction. This is your delta v. This is v, this is delta v, and this is v dash. Again, if you add these two angles, this is again this delta theta. These angles are again x and isosceles triangle, and this is 90 degrees. Which means that if you do a parallel translation of this vector over here, what will you get? You will again get this like this. This is delta v, the length is same, direction is same, and this was the direction of this delta r vector. This delta v is again perpendicular. If you extend this line of action of this vector, this is pi by 2 here, and if you check this triangle, this angle, this here, this will be bisecting this. So this angle will be pi by 2 minus x. This delta v is again perpendicular to this delta r vector, and this is again bisecting the angle between these position vectors. You can check for yourself. So the results that we were obtaining did not change, which means that the average acceleration, which was delta v over delta t, the direction of this average acceleration is towards the center of the circle. So this means that the results did not change whether we took a longer time interval or for a small time interval. This average acceleration is always directed towards the center of the circle for a uniform circular motion. But you know, instantaneous acceleration or acceleration is delta v over delta t in the limit delta t tending to 0. So this limit delta t tends to 0. So which means that we have to analyze the situation. Point P is here and P dash is also somewhere here. So this is position vector of this point P, and this P dash is also here. This P dash, which essentially means that R dash is also nearly equal to this R. So these two position vectors are nearly equal. So if this is R vector and this is R dash, in the limit delta t tending to 0, this R dash will nearly coincide with R. To show you the vector delta R in this case, I have shown some difference between the two, although there is no significant difference if you are taking the limit delta t tending to 0. So delta R in that case will be this. This is delta R and this is obeying the triangle law of vector addition. Delta R was nothing but your R dash minus R. Now we saw the positions of R dash vector. For a long time interval it was here. For a shorter time interval it was somewhere here. Now in the limit delta t tending to 0, this R dash vector will nearly coincide with this R vector such that this delta R vector is nearly perpendicular to this R vector. Do you agree with this? This delta R vector will be perpendicular to this R vector in this limit. As these vectors get closer to one another, this delta R vector will be nearly perpendicular to this position vector. So this is one thing. If you remember, we had also drawn the velocity vectors at these points. So in this case, in this limit delta t tending to 0, these v and v dash, these were supposed to be the velocity vectors at point P and P dash respectively. So these will also coincide. These will be nearly coinciding with one another. Magnitudes तो पहले से ही same था. V, this is V dash. So delta V will be again like this. So delta V, you can say in this time interval delta t tending to 0, this delta V can be said to be perpendicular to the velocity vector. So what do we conclude? So if I erase this, this is V, delta V is perpendicular to V. This means that this delta V, the direction of delta V is this. So this means that this is the direction of delta V in this limit, and acceleration is nothing but this expression in this limit. So if the direction of this in this limit is this, time has nothing to do with the direction. So acceleration ki direction will be dependent upon the direction of delta V, and in this limit the direction of delta V is directed towards the center, which means that acceleration, the instantaneous acceleration that we talk about, the direction of acceleration in uniform circular motion is along the center of the circle. So this is the direction of acceleration for the object moving in a uniform circular motion. So now the next thing was to find the magnitude of the acceleration. Okay, so if you remember, we had two triangles. One which was formed by the position vectors. I have named it to be CPP dash. This triangle CPP dash is formed by the position vectors R, R dash and delta R. Okay, and if you remember, we had another triangle which was formed by the velocity vectors, and I am naming this triangle to be GHI, triangle GHI. Now I have two triangles, one formed by position vectors and the other formed by velocity vectors, and we had already checked this, that this angle, the angle between R and R dash vectors, the position vectors of these 2 points, was the same as the angle between the vectors V and V dash. So these two angles were same, and both of these are isosceles triangles. The magnitude of V dash is equal to the magnitude of V. Why? Because I'm repeatedly saying, because this is a uniform circular motion. Uniform refers to constant speed, and the magnitude of velocity is nothing but speed. And the magnitude of these two vectors is also equal because these are the radius vectors. So this is the radius of the circle. Let it be R, and this is the speed, which is V. the constant speed v. So this means that these two angles are also x. Now if you remember, आपकी छोटी classes में आपको पढ़ाया होगा, if you have two triangles in which the corresponding angles are equal. In these two triangles, the corresponding angles are equal. So this CPP dash triangle is similar to this triangle. And you know that if this is the case, then the corresponding sides are in the same proportion. Now these two triangles are similar by angle similarity, AAA similarity. So their corresponding sides are in the same proportion or same ratio. So I can write it like CP over GH is equal to PP dash over HI is equal to CP dash over GI. You can check the order. So these will be nothing but the magnitudes of the respective vectors. ये एक तरह से length denote करें and the length of the vector क्या है, उसका magnitude है. CP is this position vector and the magnitude of this position vector is R. So you can write this like R. GH is this is speed V. Note that this is speed, not velocity. I'm writing the magnitudes. PP dash is this is delta R vectors magnitude. And HI is this is delta V vectors magnitude, which is equal to CP dash. This is again radius and which is again speed. So I will be getting this. So why am I doing this drama here? Because I know that acceleration is delta V over delta t in the limit delta t tending to 0, and I need to find out the magnitude of this acceleration. So I am searching for the magnitude of this expression. That is, I now need to find out this. ठीक है? So now if this is clear, ये अब इसकी कोई ज़रूरत नहीं है, so I'm erasing this. Okay, so I can get my delta V from here, the magnitude of this delta V. I will be using, I can use either of this. So can I write this like delta V is V over R into magnitude of delta R from here to here. Can I write it like this? So if I substitute this value of delta V here, why? Because I need to find out this. So this is acceleration is limit delta t tending to 0 of this V by R delta R over delta t. Now this is this. Now in this time interval tending to 0, what will be my delta R? So you know this is the delta R for some finite time interval. If this delta t is tending to 0, this point comes here as the case I showed you. So this P dash will essentially be coinciding with this P. So in this limit delta t tending to 0, this delta R will also come here. This arc PP dash, ये point P dash, this comes over here. In this case, what you can approximate is that this arc PP dash, this can be approximately taken to be delta R, the magnitude of this delta R. This arc PP dash can be approximately taken equal to be this delta R, and this delta D tending to 0. This delta R will become perpendicular to this R, and V dash will also nearly coincide with V such that delta V is also perpendicular to V. तो ये चीज़ें हो जाएंगी, and this delta V also tends to 0 because this V and V dash will nearly overlap in this limit delta t tending to 0. So arc PP dash is equal to the magnitude of delta R. So what can I say about this magnitude of delta R that we need here? This arc PP dash is the distance moved along the circular path by an object which is under the uniform circular motion, which is traveling with this uniform speed V for some time interval delta t. So this can be approximately equal to this. This is nothing but speed into time. The distance along this arc pp dash, जिस पे move करने की object की velocity constant है, which is v, and if the object moves for some delta t time, the distance moved is pp dash. Now I will simply be substituting this value over here. I will be getting this expression as magnitude of A is v by r. Now this expression is in the limit of delta t tending to 0, so I can drop this. I can simply put the value of this. So this is v into delta t divided by delta t, which comes to be v square by r. So that the magnitude of acceleration of an object in a uniform circular motion is v square by r. So some quick points are as follows. If an object is moving in a circle of radius r with a speed v, the magnitude of the acceleration will be v square by r. Since the acceleration is always directed towards the center of the circle, it is also called centripetal acceleration. This term was proposed by Newton. Centripetal comes from a Greek word which means center seeking. Since the magnitude of centripetal acceleration is v square by r and v and r are constant, r is the radius of the circle, v is the magnitude of velocity, which is speed, and for the uniform circular motion the speed is constant, which means that the magnitude of the centripetal acceleration is constant. However, since the direction of the acceleration is always pointed towards the center of the circle in which an object is moving, the direction of acceleration is continuously changing, and since acceleration is a vector, this means that centripetal acceleration is not a constant vector. It's a vector of constant magnitude, but it itself is not a constant vector since the direction is always changing, so that it always points towards the center of the circle. So that was all for today. I hope you liked my video. If you do not forget to give it a big thumbs up, and do write your beautiful comments in the comment section below. Do not forget to subscribe to my channel. You can also follow me on Instagram. I'll be back with my next video. Till that time, do not forget to take really good care of yourselves. Bye bye.